That rooftop tent didn't come from an aftermarket catalog. It came from the factory. Chevrolet just destroyed the boundary between production truck and expedition rig, and the overlanding community is not ready for this. There's one integration decision in this build that no American truck manufacturer has attempted at the factory level, and by the time we get to the verdict, you'll understand exactly why it changes the economics of overlanding in this country. Is this worth the money? My answer is going to surprise anyone who spent the last 5 years building their own rig in the driveway. We're covering the exterior architecture, what's happening inside that cabin, and the performance story. But I also need to tell you where this project came from, because word I'm hearing is Chevrolet didn't build this alone, and the partner they brought in is not who you'd expect. Here's what stands out first, and it's not the roof tent, it's the system thinking behind it. Word I'm hearing is that Chevrolet's performance division worked alongside a Tier 1 expedition outfitter, one that's been supplying overland infrastructure to military and search and rescue programs for over a decade. The goal wasn't to bolt accessories onto a ZR2. The goal was to engineer the load distribution, electrical architecture, and chassis reinforcement as a single integrated system from the ground up. Why does that matter? Because every aftermarket overlander knows the problem. Add a 150-pound RTT, a 60-pound rack, recovery boards, and a winch, and you fundamentally change the vehicle's center of gravity, suspension geometry, and electrical load, usually without the factory accounting for any of it. This is what I'd call factory-integrated load path engineering. The roof rack mounting points on this build reportedly tie directly into reinforced B-pillar and roof reel nodes, not sheet metal. That's the structural difference between a bolt-on and a proper build. But understanding why the exterior is engineered the way it is only matters if the interior delivers on the same standard. Let's go inside. Step inside, and the first thing that hits you is the contradiction. This is a truck designed to sleep in the dirt, and the interior looks like it belongs in a $70,000 sedan. Diamond-quilted leather across every seat, red contrast stitching, alcantara suede inserts on the door panels, and a red ambient lighting system that runs the full perimeter of the cabin. It's cohesive, it's intentional, and for this segment, it's genuinely unexpected. The infotainment is a landscape orientation screen that appears to be around 11 to 12 inches diagonal, paired with a fully digital instrument cluster running dual circular gauges with a Chevy bowtie centerpiece. Physical climate controls are retained directly below the screen. That's the right call. For anyone who's tried to adjust cabin temperature on a rough trail with one hand, keeping tactile controls is a functional decision, not a styling one. The Drive Mode button on the center console is worth noting. This is the gateway to the terrain management system, and in an overland context, that button is going to get used more than anything else in the cabin. Speculative tech number 2, what I'd call thermal ground analysis, a forward-facing infrared camera array that reads ground heat signature to distinguish compacted hardpack from soft or saturated soil, feeding that data directly into the traction management system before the wheels touch the surface. It's the difference between reactive grip and anticipatory grip. In a bog situation at 3 a.m. with a tent full of gear on the roof, anticipatory wins. Where I think they've left something on the table is rear passenger space. The Colorado's crew cab is workable, not generous. If you're regularly running 3 or 4 adults on multi-day trips, that's a real constraint. It doesn't disqualify the build, but experienced overlanders will feel it. The interior makes a strong case. Now let's see if the exterior and the suspension back it up. Here's a piece of that origin story. The outfitter Chevrolet worked with reportedly supplied the RTT design spec, the bed rack load ratings, and the electrical integration brief, all of which were handed to GM's engineering team as a requirements document, not an afterthought. This wasn't a dealer add-on program. This was a co-development. And that's exactly why it looks the way it does. Start at the front. That bumper is a full steel bash unit, not a cosmetic overlay, with factory-integrated winch mount rated for a 10,000-pound pull and twin red recovery shackle points. The hood scoop is functional, feeding cooler air to the intake under load. The headlight cluster uses stacked multi-element LEDs that run the full width of the face. This is a purposeful end-to-end, not a styled one. The lift on this build appears significant. I'd estimate 3.5 to 4 inches of suspension lift based on the wheel arch gap and visual proportion relative to the standard ZR2's 8.9-inch ground clearance spec. The mud terrain tires look to be in the 35-inch range, which is the functional threshold for serious rock and sand work without destroying highway manners entirely. The rear rack system carries recovery boards, a fuel can, and the RTT, a combined load I'd estimate at 200 to 220 pounds, which is why that factory load path integration matters structurally. Design and load engineering mean nothing without the right powertrain underneath. Here's what I think they've done. The Colorado ZR2 platform baseline is the 2.7-liter turbocharged four-cylinder, producing 310 horsepower and 390 foot-pounds of torque in high-output trim, paired with an 8-speed automatic. For this Overland Pro, the strong speculation is a recalibrated torque curve prioritizing low-end output, with the peak torque window shifted lower in the rev range. In overland applications, you don't need peak power at 5,500 RPM. You need pulling torque at 1,800, crawling over a ledge, winching out of soft ground. Speculative tech number 3, predictive differential lock, using GPS trail data and IMU sensor input to pre-engage the front or rear locking differentials up to 2 seconds before the system detects wheel spin. Current locking diffs react after slip occurs. A predictive system prevents the slip entirely. For a loaded overland rig on loose terrain, that's not a convenience feature. It's the difference between momentum and getting stuck. All of that brings us to whether any of this engineering ambition is priced to actually reach its target buyer. Now, here's what I actually think, and I want to be completely straightforward with you. The reason this build exists is because Chevrolet looked at what experienced overlanders were spending above MSRP, $25,000 to $40,000 in aftermarket builds, and decided to capture that money at the factory gate instead. That's not cynical, that's smart. And the execution suggests they understood the buyer. Pricing. For a factory-integrated build at this specification level, I'd expect a window sticker in the $62,000 to $72,000 range depending on configuration. Context: a base Toyota Tacoma Trail Hunter runs around $55,000. A comparable aftermarket ZR2 build, truck, rack, RTT, winch, recovery gear, lift, lands you at $75,000 to $85,000 when you price it honestly. The Overland Pro lands inside that window with factory warranty coverage on every component. That's the value argument, and it's a legitimate one. On depreciation, factory-built adventure packages from GM have historically held value better than equivalent aftermarket builds because financing, insurance, and resale appraisal all treat them as a single vehicle. That matters at trade-in time. Here's the call. If you're someone who does 2 or more multi-day overland trips a year and you've been pricing RTT setups and lift kits separately, this is the most financially rational entry point in the midsize segment right now. The factory integration genuinely changes the math. If you're primarily a weekend day driver or occasional dirt road explorer, the standard ZR2 at $45,000 gets you 80% of the capability for significantly less money. That's the honest answer. And that integration decision I mentioned at the open? Factory load path engineering tied to the B-pillar and roof rail nodes. That's the thing that makes this build structurally different, not just visually. At the open, I said that rooftop tent didn't come from a catalog. Having walked through the engineering and the economics, the more I look at this build, the more I believe that's the most important thing about it. Factory intent changes everything. I'd love your take, especially if you built your own overland rig from scratch. Drop the real cost below. How this stacks against the Tacoma Trail Hunter on the trail, that's the next video. Subscribe if this kind of analysis is what you're here for. See you in the next one.